Good morning. This is week 5. In today's week, we will discuss about arrays. Okay. In last week, you did basically in workshop database programming. Okay. You created database connections. You retrieve information from the form and saved in the database. In this week, you will continue with the last week workshop. Okay. So databases are the one way we manage the information. Okay. But those are external storage. In order to process information within the memory, we need some data structures, and we all know arrays are one of the available data structures in which we can save information, and we can compute something on that information, and then we may store that information in databases. So today we will look at arrays, and we will also see how they help us in decision making process, especially we're talking about business logic in a program. In business logic, arrays have a critical role to play, and how they help us in nested decisions. Up till now we all know that if-else structures we can use for nested decision making. How arrays can provide us a better solution, we will look at one example. Like constant variables, we will also see the role of constants in arrays. If we define the size using a constant variable, what are the advantages we can get? So through some examples we will look at this one as well. And once we have information arrays, we need to search for specific elements, specific information. We need to search arrays, and we will look at some example as well. There are different ways we can use arrays to capture the information, and we will look at parallel arrays. We will also look at associative arrays in this lecture. And it may be possible that when we search array, we may be searching against a certain range of values. Okay, so how we can tackle that problem, we look at as well. And the role of for loop is very critical when we are playing with arrays. And after this, I will there are a couple of code examples which are uploaded on the Blackboard. I will just show you some code how dynamically index is being generated to capture the information from the form, and that will be very helpful for your assessment 1. Okay, and also if there would be any questions regarding assessment, I will be happy to answer them. So what are arrays? How we define them? Collection of certain type of data. So remember we discussed initially that variables are way to store information, but there are certain variables that are of same data type, and we can refer those variables with the same name. If you look at your assessment 1 form, there are maybe 20 or 25 fields and 4 or 5 columns. So there are around 100 fields, input fields. Now you can create 100 variables. Your program will work, but that's not the efficient way. Managing those variables, assigning value, retrieving value, it's very hard. But you see that each column is carrying a unique data, carrying a same data type information. Competitors, all information would be in strings. So you can create string data type, and you can store all the competitors' name. The next field was medals. Okay, was there any number field in there? If there's a count field over there, total number of medals, then you can define int array, and you can store all the values in there. In short, when variables have same data type and we can refer through the same name, then we can use arrays. And how we differentiate them? Then we differentiate them through index. Okay, each index we know that can differentiate one variable from another variable. So in short, we have grouped variables together which were previously separate. We group them together under the same name, and we differentiate those variables through a subscript which we call index. And you can see example over here. For example, prices is an array, and this tells us the size of array. So in this case, prices size is 3, and its index starts from 0 and goes up to 2. And in memory, this is how array information is stored. It would be contiguous in nature. Okay, they will store one after another. Okay, so when we say price 0, it refers to the first index. Okay, price 2 will refer to the third index. Okay, so we use arrays to store information in this fashion. So some terminologies, each item in array is called element, and as I mentioned, they are stored contiguously. size of array will tell us how many elements that array can hold. Okay, and as I mentioned, array started from the index started from 0 and goes to size minus 1. Okay, and when we say populating array, we means basically adding data into array, and this is how we populate an array. This is one way we can assign values directly to specific indexes. In PHP, we can define an array and we can assign values while we are defining it in this fashion. Okay, so this was definition, and then we assign the values to the index. So definition and assignment population of array was done in 2 steps. Over here, especially in this syntax, we are defining an array and we are assigning the value. Similarly, in C#, this is a syntax we can define an array. Okay, so syntax will vary from language to language, but semantics are same. No matter which language you're working, arrays works in same fashion. So how they can help us in nested decision making style? So in order to understand this, let's look at this example. There is the HR department, and they want to identify that there are certain employees who have basically claimed that they are sporting certain dependents, and they want to know that how many people are depending, how many of their employees are not sporting any dependent, or how many of are there that are sporting 5 dependents. Okay, so they want to get this count. Maybe they want to give some bonus or so on. So eventually they need this kind of report, which will tell us that, so this is the count of people and this is the respective number of dependents they are supporting. So this is the reports they need to generate. So in order to build the program, we all know that we can use if-else structure. If you look over here, so what this program will do, basically it will have some pop-up screen asking the user to enter number of dependents. Okay, and user will enter number of dependent, and that will get saved in this depth variable. Okay, depth variable, and depending upon what user has entered, we will do some activity. So if you look over here, we basically needs the count for each category. Okay, so we have created these variables which go, these are 6 variables. So we have 6 counters. Okay, because in this, if you look at this, we have 6 categories. Okay, but in order to capture these 6 categories, we have 6 counters. So if user enters 0, means he does not support independent, we will basically increment that counter. If he says he is supporting 3 or 4, accordingly counters would be incremented. If he enters 5, then last else will be executed and it will increment the last variable, which is count 5 variable. So very simple, and it will work for us. The functionality we want to achieve, we can achieve in this fashion, and this way we can generate a report at the end after doing this computation. But there are some issues with this style. What do you think? What are the possible issues? What are the possible concerns you can identify with in this style of writing? It's like big readability issue. Maintenance would be an issue. Okay, this could be one issue. What else?
To perform more checks per user entry, because it needs to check each individual number independently.
So multiple conditions we are checking again and again, but this if as structure, yeah. Okay, again it goes back to readability and maintenance. What if there is a user? Right now they are assuming that the maximum categories they have up to supporting 5 dependents. Maybe there's one person who's supporting 8 dependents. In that case, if that case come across, then they have to add one more if-else structure or 2 if-else structure, and then they will be able to cater that case. So there are a few issues in this, and especially this is the hard way, because it has some readability issue, maintenance issue, and application does not scale if we have some special, if we have further cases. If assumption is wrong, there are further cases, then definitely we have to add more if-else structure into the code. So this was the issue. Now arrays can help us to reduce the number of statements. Okay, so instead of having those 6 variables which we had previously, the counters, we can define an array of counts, and the size of array would be 6. And each index would be giving us same functionality, working as a counter that we had on previous case. Okay. So this is counter 1, this is counter 2, and so on. We have 6 counters over here. And using the subscript, we can identify the index for that counter and we can increment it. If user enters 0 dependents, then we go to the 0 index and we can increment the value that is residing on the 0 index. So we are counting again number of dependents. Same logic, but over here we have used arrays. Okay. And through subscript, we are identifying which counter needs to be incremented. Whatever current value that counter is holding, we are incrementing it. So we have used arrays rather than variables. So it does reduce some statements. Instead of defining those variables separately, we have now one statement over here which is declaration of array, and then we are doing it. So did it make a much difference? We still have a complex structure, isn't it? Still hard, readability issue, scalability issue. Okay. So still hard. What do we need to do? What do you think? How we can improve this program?
Use an array to replace the decision making by making the user input address a specific point in the array rather than checking the user input against each.
That's the ultimate conclusion we will draw from this. Okay, that's the ultimate conclusion we will draw. If you look at this code, if dependent is 0, count 0 is getting incremented. If dependent is 1, whatever is on index 1 is getting incremented, and so on. So there is some relationship. So why we are hard coding this 1, 2, 3, 4, and 5? Loop, again, loop is one condition. But right now what we can increase is, instead of having that hard coded 1, 2, 3, we can use the dep, because dep refers to the specific index in an array, and accordingly we are using that counter to reflect that category. Okay. So we replace that hard coded index with this dep variable. Okay. So this improves the program. So now we are using variable instead of hard coded indexes. And if you look carefully, all these statements are similar. There is no difference. If there is no difference, then why we have these if-else structure? You getting it? Okay. So in short, we need only one statement, like your fellow students are mentioning. We only need one statement that can give us entire functionality. So when user enter, we just have to go to that whatever user enter, we have to identify that index and increment the value that resides on that index. We are identifying that counter and incrementing that counter. So this one statement replaces the entire if-else structure. So it improves the readability, it improves the maintenance. Okay. So we address those issues. Okay. And now program is very simple. One statement doing all this. But what about scalability? If we have to add more cases, what do we need to do now? Right now we have 6 cases. If number of cases increases, what we need to do is, why another variable? Where? Yeah, so we have to increase the size of array. So we have to do something, but it's not that much as we have to do before. So over here we have to increase the size of the array. We have to make it 7, 8, 10, 12, whatever the categories are, and then this statement we don't need to change at all. This will continue working. This will continue giving us the functionality. So you see, this is how arrays can help us in nested decision making. So you have to identify whether you should go for if-else structure, or you can use arrays to replace this. But still we have some issue which is regarding the maintenance. If you have to increase, if you have to cater for more categories, you have to increase the size. Okay. Now this is the flowchart representation of the program which we discussed, and this is a pseudocode. So you can see that we basically do some housekeeping, then get ready module is called, which is asking user for input, and user will provide input, and then we count the dependents, which is incrementing the specific index that belongs to that category, and then finish up. In finish up, what we are doing, we are looping through array and printing it. So we start this DEP variable from initialize with 0, and unless we reach the maximum size, we are printing the counters over here. So this is the enter, and this is the pseudocode. So in previous case, as I mentioned, if we have to increase, if we have to cater for new cases, we have to increase the size. Okay, how we can address this problem, or we can better manage this problem? Now let's look at the constants. So we discussed about constants when we were discussing variables, and I mentioned why we need them. Why we need constant variables? Yep. So that the instructions that are part of that program, they should not be able to change that variable value, because during execution of the program, instructions can access the variables, they can manipulate the variables, you can update the variables. So we want the value of that variable to remain constant throughout the program. Now, how we can use constant in arrays? We can use them to hold size of an array. So in previous cases, if we define the array, we were basically giving hard coding the size over there, like 6 we were doing before. Okay, but if we define a variable like this in constant Indiana is equal to 5, then we can use this variable to define size of an array. Okay, so we can use constant in this fashion, and once we have this, then wherever we are traversing the arrays, okay, I will show you a couple of examples afterwards where we were using for loop. So when we have to traverse arrays, we instead of hard coding the value size, we can use the variable, the constant variable, which is Indiana in this case. So this basically increase maintenance of your program. So if you are catering for more cases, then only this variable needs to be changed. Then rest of the programs does not need any modification, because this variable is being used in an entire program. Okay, so one change will be able to accommodate new categories over here. They can also, array values can also be used as a constant. For example, in the case of this month, so these are constant values. Okay, and we can use it in a program, or they can be used as a subscript as well. For example, if I just echo sales array Indiana, it will basically print the value which is basically the last index of the array. So we can use constant in arrays in different ways, and if we use this, especially the size, if we define the size as a constant variable and use it, it basically increases the maintenance of program immensely. So now let's look at searching for array. So we have array, we are able to store values in array, and now we are going to search values. Have you taken data structure course? Yeah. So in data structure course, you learn about different algorithms, bubble sort, linear sorting algorithms, and so on. If you not, then these are basically algorithms that help you to, you have a data structure like array, and you have multiple elements, you can sort them, you can learn different algorithms, how to better manipulate, manage those values and so on. So linear search is basically, if you are looking for a certain value, certain item, you start matching that item with all the possible items in an array that you have. So one by one you match with them, and once you find an item, you basically bookmark that index, and you can use that value for your business logic. So why we need this? Let's take an example of this mail order business. What this business do, basically they received orders from the customers in mail, and what they receive is basically an item number. User asking for certain product. So the clerk that received the order, basically he needs to identify whether that item does exist in the store or not. Okay, it has to basically do a search of against that item in the store, and if it does find it, then he can basically proceed further. So how we can do this searching when we have data in arrays? Okay, so this is a simple program. As flow chart, basically we do some housekeeping in which we define certain variables like item which need to be searched. This is when user will give us some value, we store that value in this variable, which is the number variable. Then we have a size of, we have variable size, and we are using that size variable to define array size. Okay, and these are the items that are stored in an array. Okay, so size is 6, it goes to index 5. Then we have one boolean, not boolean string over here, but it holds yes or no value. Okay, whether item is found or not, and we will see how we can use it in the program. So this is some variables we define it. This is housekeeping. Then we basically have this module which is get ready, and get ready basically asks user to enter item number, okay, which is clerk will be entering the item number, or type in finish to finish terminate the program. And in finish basically it will provide us the output summary that okay, whether the item is found or not, or how many byte items count is there, and so on. In short, it will give us some results. Now let's check what this find item does. Okay, so if you look over here, we define this variable found it, and we start with this variable and we initialize it to n. So when we are starting the search, we set this flag variable to know so that our program can move further. So this is a subscript. We initializing with 0 because we have to start from 0 index, and we will go to the last index of an array. So this is a loop which basically compare this subscript with size of an array. If this condition is true, then it will go and it will basically do some matching. If you look over here, item equals to valid item, and we have given subscript as index over here. So in case of 0, whatever is the 0 index of the array, it would be matched with an item over here. Okay, it will do some functionality. If it is founded, the variable this boolean this flag will basically y will be assigned to this flag. We will increment the subscript and go back again. We will continue this loop until we reach the end of the array. Okay, so this is very simple linear search functionality over here. So once we finish, once this condition is false, when size subscript will become is greater than size of an array and found it equal to yes, then this will happen. It will be displayed. Otherwise, it will basically display further information that how many bad item counts you have done so far, and so on, and it will finish terminate the program. In short, this is the functionality that we are looking into critically. Now, if you look over here, if let's assume the size is 10 as it was on previous slide, okay, and the item we are looking for is 100. If you look over here, item 100 is not over there. Okay, so if we start with this size, so when it is 0 and we have item 100 over here, 100 would match with 106, which is on the first index. Okay, so this is on first index. It will not it will be not matched, then it will go and it will go to the next subscript. So it will iterate through all these indexes of the array. It will compare with 108, 307, 405, 457, 688, and match will not found. So in this case, a variable would be n, and this statement would get executed. But if I change this to 106, if I change item from 100 to 106, and we know that 106 is residing on the first index, so on first go it will get matched, this statement will get executed, and it will go back and will continue for the second item, third item, and fourth item, fifth and sixth item. Okay, so you can see that although we were able to match the item on first iteration, but the loop is still going through. Linear search is still going on. Okay, so this is an inefficient way of matching the item with the items that are in array. So how we can improve this situation? So we were able to find the item. We were able to initialize the variable, update this variable found it to yes, but our linear search is still going on unless we reach the maximum size of an array. So how we can improve this situation? What do you think? Stop search how? Not break statement over here. This is flowchart. So what is the best way we can do over here? How we can modify this program so that as soon as item is found, it should not go for further matching in an array. and we are using this flag variable over here. Hmm? Any idea? So this is right now the criteria we are considering over here, subscript is less than size, and we have another flag variable which is founded. If we use this flag variable over here along with this criteria, it will work. As soon as this we will assign y to this founded, and it loops, it goes back to the criteria, and criteria does have this variable as well in there, then loop will break. Okay, so this is how we can improve it. So this is the pseudocode of this program that we just discussed, and this is the solution which I was talking about. As soon as we find the item, linear search should not continue. It should give us a result that item already exists, and clerk can proceed further. Right now we have an array of size 6. It may not be significant. Even you iterate the entire array, that's fine. But in enterprise level applications, the array size may be in thousands. The product you are loading from the database into array, they may be in thousands, and in 1,000 efficiency matters a lot. So as soon as you found an item, you should break the loop immediately. So this criteria is very critical, which you need to identify what are the important variables on which your loop should continue working on. It should continue linear search. Okay, it should not be only the size of an array. Size of array is one factor, but there are other variables like founded, the flag which we use. It should be used in this loop condition as well. Okay, and it will definitely improve performance a lot. And you can see the pseudocode over here. This is how it will look like. Okay. So that was regarding linear search. Okay. So now we are going to talk about using parallel arrays. In your assessment, you have basically 4 columns. You are basically trying to capture competitors' information, and then you are trying to capture medals information, and so on. Now, in array, you can only capture one data type. Okay, if you are capturing competitors' information, you can define a string array. If you are capturing some other information that may be of integer data type, you can define integer array. But how you basically manage them together so that at the end, when you are trying to generate report, you are able to print each and everything. When you are trying to calculate the medals, you are able to compute that these medals belong to this person and they are this much in number. So how you can correlate them? Over there, parallel arrays you can use. They provide a solution. So what are parallel arrays? Let's look at this example. In previous case, we were just looking at the items number. Against item, we were trying to identify whether that item belongs to our warehouse or not. If it does exist in a warehouse, we can basically ship that item to the customer. What if customer is on the phone and customer has given us an item and he wants to know the price as well, so that then he can place an order. So in this case, our programs not only have to tell that whether item is found or not. If item is found, then the program should also tell what is the price of the item. Okay, so how we can implement this? So what we can do, if you look over here at the bottom of this slide, so this array, the top array is basically holding the item numbers. Okay, the way which we have previously. Okay, so it stores all the items number in there. If we define another array, and we basically create a logical relationship between two, there is no physical relationship in this case. Okay, two arrays are independent, but we know that this price array, the index 0 basically holds the price of an item that is being present on index 0 of this item array. Okay, in simple, this item, the price for this item is stored in 0 index of this price array. The price of this item, which is in item array, the item is price is stored in this index of price array. So we basically can create indirect relationship, and programmer has to understand this relationship. While he is doing coding, he can create these logical relationships, and then he can manipulate the information and can generate the reports accordingly. So in this case, we are relating the subscripts. So zeros index in one array correspond to zero index in another array. Okay. So like in your database, you create primary and foreign relationships. So you can think of primary and foreign relationships over here. So and how those relationships are created? They are creating through indexes. Each index is basically corresponding to array in another index, and it creates a relationship. Yes.
Do you think it'd be better to keep them separate or make into like a 2D array?
2D array is another solution, which we'll talk about that. Okay, but parallel arrays provides you one solution. Parallel arrays are easy to manage. They're easy to conceptualize. It's one-dimensional array. When you increase the dimension, conceptuality increases, the complexity increases, and in order to visualize the scenario, programmer has to be more vigilant and so on. But 2D arrays does provide a solution as well. So indirect relationship is created, and using that indirect relationship, you can code the logic. So in this case, if you look over here, using parallel arrays, the same program is now being modified using parallel arrays. So we have this valid item array, and then we have valid prices array. Okay, and this is housekeeping, the stuff which we discussed previously. But important thing is over here, if as soon as you found the item, okay, the subscripts at which you basically the item was matched, the same subscript, using that some subscripts you can pick up the price. Okay, and you can display it to the clerk that this is the price of this item, and clerk can basically tell it to the customer, and customer can proceed further whether you want to place an order or not. Okay, so if there are 5 attributes of a product, price, color, and so on, you can create 5 arrays and so on. So for every attribute, you can create one separate array, and once you are able to find the item, you don't need to do any linear search or further search in the rest of the arrays. Index will provide the solution. You know the index, and then in corresponding arrays, you can pick up the respective values. Okay, and this is the pseudocode of the previous program. See, and this is returning the price, and price can be used further in the program. Okay, so searching for an array for range of value. In previous cases, we were just looking at one-to-one comparison. Okay, we had one item number, and we are matching it exactly with one number. This is what logic was required. If we need further attributes of that product, price, color, and so on, we can just go to the corresponding arrays and pick up the values and so on. But in certain scenarios, we may need to code logic as is being depicted on this program, where we have to cater for range of the values. For example, in this case, if you look over here, if user is doing a shopping, if user purchase up to 8 products, then discount is 0%. But if he purchased between 9 to 12 products, then discount will be 10% and so on. So this is a business scenario, and in order to address this scenario, we can define a solution using a parallel array. For example, if you look over here, we can have an array of quantity ordered, because in this case we are looking for quantity order. If user order one item, then we know that this one item, if purchase one item, then index 0 of that array corresponds to index 0 of this array, which is num discount. Okay, so discount will be 0. So this array size is 76, so does this array will be of 76 size, and we will have, for example, if user orders 76 items, then discount would be whatever is on 75th index of this array. Okay, so parallel arrays, we have order quantity being the quantity being ordered by the customer, okay, in one array, and in corresponding array we have what would be the discount. If quantity is 33, and whatever is the discount on 33 index of this discount array, it will get applied. So using these arrays, this is very simple solution. But there are certain issues over here as well, and the issues are quite apparent. Especially in this case, you see there's a lot of repetition over here. Okay, and again memory is being used, maintenance would be difficult, and so on. So these are the issues which we will encounter, and especially if customer orders more than 76, your program needs to modify as well. The issue which you saw in previous cases meant especially scalability of your application, we have that issue over here as well. So what we can do, instead of defining that array of 76 discount percentages, we can basically define a discount array of only 4 values, which is basically there are 4 categories. So if user purchase products more than 26, the discount will be 20%. If they purchase more than 13 but less than 26, discount will be 50%, and so on. So this is what we can do. We can define an array of size 4 because there are 4 categories of discount. Okay, and we define them over here. Now, with the help of loops, we can basically achieve the entire functionality. Okay, and how we can do that? This example will make more sense to you. First of all, there's some housekeeping, and then in housekeeping we are basically define the variable, and then we ask the user to enter the quantity. Once user enter the quantity, this is the business logic that is going to work now. Now I'm going to explain how does this work, and in finish it will basically finish it. Now if assumes user entered a quantity 10, okay, user basically purchased 10 items, and what will happen over here? First of all, we have this variable x, which is initialized with size -1. And what is the size of array? 4. So this x variable will contain value 3. So x is holding 3 value, and we are using x as a subscript for this array, which is quantity limits. Okay, so the quantity user has ordered the limits we have in array. So we initialize this with 3. And what we have in quantity? We have 10 over here. Okay, so at index 3 we have quantity is 26. Now 10 is less than 26. Yes, the loop will the condition is true, then it will go and decrement the x variable. So x will become 2. Okay, so then we will match 10 with 13. 10 is less than 13. Yes, we will decrement the variable again, and x will become 1, and 10 will be matched with whatever we have on index 1 of this quantity array, which is 9. Now loop will break. So in short, we are traversing the array in reverse fashion, and while traversing we are comparing the quantity being purchased by the user with these values, which is basically the maximum range over here. And when the loops break, then we know that the item that basically the number of items that user purchased is basically in the previous category, which in this case was 13. Okay, sorry, this one between 9 to 13, and 10% discount will apply. If I summarize, I compare 10 with 26. 26 was greater and 10 was smaller. Condition was true. We decrement the size, decrement the x variable, which we are using as a subscript. Okay, and then we compare 10 with the 13. 10 is less than 13. Okay, so we continue the decrement of the variable subscript, and we went to the to check with the next category, which is 9 to 12. And now 10 is greater than 9, loop will break, and this is the category which whatever we have stored in the corresponding array, which is discounts. That discount percentage will get applied on the product. So in this case, 10% will get applied on the item. Okay, if you dry run on your paper, you will get this logic. Simply we are traversing the array in reverse fashion. In this case, we have used lower range value. You can also use upper range value. It depends upon you how you basically build your logic. So instead of using 9, 0, 9, 13, 26, you can use 8, 12, 25, and so on. Okay. So this is how you can basically use arrays to search for a range match. Okay, and instead of defining parallel arrays, one-to-one correspondence, you can capture the categories in arrays, and then using for loops, you can basically build your logic. Okay, and this is the pseudocode of that program. So any questions? What we have covered so far? It's pretty easy. If you have worked with arrays, then you will be able to grasp this concept quite easily. We can take 10 minutes break, and then we will start with remaining with array bounds. That when we traverse arrays, we have to be careful with the array bounds.